Okay, so one more problem finding absolute maximums and minimums. The function here is called h of t, so it's a function of the variable t, and they want us to find the absolute maximum and minimum value of this function on the closed interval 3 to 5. Okay. Now, if you know a little bit about this function, you know it's going to have a problem when t is equal to 2. Okay, in fact, it's going to be undefined there. But if you look at that doesn't really matter. Okay, between 3 and 5, this function is well defined, and you could actually go ahead and graph it on the calculator and see in advance that there is no problem here. But between those 2 points, the function will have a maximum, it will have a minimum, possibly somewhere in between, possibly at the endpoints themselves. Okay, where is it? Okay, well, first of all, we need the derivative. Okay, so h prime of t. Well, for this one, it's a function that's a fraction, so we need to use the quotient rule. Quotient rule says take the derivative, the denominator, t minus 2, okay, times the derivative of the numerator, which is 1, okay, minus the numerator times the derivative of the denominator, which is also 1, over the denominator squared. Okay. Now remember, the variable here is t, but we treat it just like it's x. There's no difference. We just used a different letter in this one for some reason. So well, I can multiply this out and cancel. I get t minus 2 minus t. It's going to be negative 2 over t minus 2 squared. Okay. So here's our derivative. Now remember, to find where the maximum and minimum can occur, it can only happen at critical numbers. Okay. What are the critical numbers of this function? Okay. Well, actually, technically, there are none. Okay, is this ever equal to 0? Well, a fraction can only be 0 if the numerator is 0. Okay, negative 2 is never 0. Is it ever undefined? Okay, actually, yes, it is undefined when t is equal to 2. Right? If t is 2, this will be 0 and we'll end up dividing by 0. Okay, but 2 doesn't work in the original function either. So technically, the function can change from increasing to decreasing at that point. Okay, but it's also a point where the domain doesn't exist. So yeah, I suppose in the book, probably you would, for our analysis of increasing and decreasing, you'd say there's a critical number when t is equal to 2. Okay, that is a point where the function can change. It's where the derivative is undefined. Okay. However, okay, we throw this point out for our problem because, remember, to find the maximum and minimum on this interval, we only test those endpoints and any critical number in this interval. Okay, 2 is not in that interval, so the function can't have a maximum or a minimum when t is 2. Okay. Now, since we don't have any critical numbers in this interval, the maximum and minimum have to occur at the endpoints. Okay. So what is h of 3? Well, h of 3, if I put 3 in for t, and remember, to find maximum and minimum, you have to put those points into the original function. You get 3 over 3 minus 2. It's 3 over 1, which is 3. Okay. And what about 5? Well, h of 5 is 5 over 5 minus 2. It's 5 over 3. Okay. So I had 2 possible locations of the absolute maximum and minimum, and I can see pretty clearly now which one is which. Okay. 3 comma 3, well, that's the largest y-coordinate. Okay. So that's the absolute maximum. Okay. The other point, at the other endpoint in this case, is 5 comma 5/3. Okay. 5/3 is about like 1.6, something like that. So this has to be the absolute minimum. Okay. Of the 2 points where we could have an absolute maximum or minimum, this one has the larger y-coordinate, this one has the smaller. Okay. So we don't have to test any number in between 3 and 5. None of those numbers are possible locations for maximums or minimums. Okay. Now when you graph this function, it's probably the least interesting function we've looked at when restricted to that interval. Okay. What you'll see, again, and by the way, I'm graphing this on the calculator. Instead of typing t over t minus 2, just type x over x minus 2. The calculator doesn't care if you call the variable x or t. For graphing, it needs x. So x over x minus 2 would be the function. And if you look at this just from 3 to 5, so let's see, here's 3, here's 5. And again, no surprises. 3 comma 3 is right here. Oops. 5 comma 5/3 is right here. The graph of the function looks something like that. Now it does get a little bit more interesting to the left of 3, and it flattens out to the right of 5. But between these 2 points, pretty clear. Maximum right here, absolute maximum at 3, 3. Absolute minimum at 5 comma 5/3.